Hi everyone, welcome back to PRAKASAM tutorials. In my previous video, we have discussed about mean value, mean square value and variance of a uniform random variable. So now here in this video, we are going to discuss about movement generating function and characteristic function of a random variable. So now here the random variable capital X is the uniform random variable. So we know that the definition of movement generating function is mx of t is equal to expectation of e power tx, which is equal to integral a to b e power tx fx of x dx. So now here fx of x is the uniform probability density function. So this is the uniform probability density function. Fx of x is equal to 1 by b minus a for x is equal to a to b. And substitute fx of x value into this equation, we get movement generating function mx of t is equal integral a to b e power tx into 1 by b minus a dx. 1 by b minus a is constant, that is written before integration. We have mx of t is equal 1 by b minus a integral a to b e power tx dx. Integral e power tx dx integration is e power tx by t. So we have 1 by b minus a e power tx by t over a to b. So now substitute upper value of x and lower value of x. We get 1 by b minus a into substitute upper value of x e power tb and substitute lower value of x. We have e power ta. So take the LCM. T is the LCM. So e power tb minus e power ta by t. So therefore mx of t is equal e power tb minus e power at e power bt minus e power at by t into b minus a. So this is the equation of final expression of the movement generating function of the random variable. Movement generating function of uniform random variable. Next we can derive characteristic function of a uniform random variable. So the characteristic function of the uniform random variable can be derived into two ways. And one way is from the definition of the characteristic function, and second way is we can determine characteristic function from the movement generating function of the random variable. So now here we can derive the characteristic function of the uniform random variable second method, and this is the final expression of the movement generating function of the random variable. So in this equation, small t is replaced by j omega. We get characteristic function of the uniform random variable. So pi x of omega is equal movement generating function at t is equal to j omega. So this is the expression of the movement generating function expression of uniform random variable. In this equation, small t is substituted by j omega. We get pi x of omega is equal e power b j omega minus e power a j omega divided by j omega into b minus a. So therefore, pi x of omega is equal e power j omega b minus e power j omega a by j omega into b minus a. This is the final expression of the characteristic function of a uniform random variable.